For problem 5b, again, we're doing differentiating a function. In this case, we're differentiating a piecewise function that's defined here. So in differentiating a piecewise function, all you're doing is doing each piece individually, and your derivative should also become a piecewise function. There's nothing really special about that. So we just have to take the derivative of this piece, and that will be the derivative piece for x greater than -1. And then we take the derivative of this function, and that'll be the derivative for x less than or equal to -1. So to do this, we just do each one individually, and the top one here, this is a quotient where nothing would cancel. So we're just going to use quotient rule. So let's start by just doing the derivative of this piece here. And if you remember, we just did quotient rule in the previous problem. I'm not going to write out the formula again. If you need to see it, check on problem 5a. So we're going to do the derivative of the top, which is 2x, times the bottom, which is x plus 2, minus the derivative of the bottom, which is just 1, times the top, which is x squared minus 1. That's all over the denominator squared, x plus 2 squared. And our entire function was negative, so we put a negative sign there. So now we just need to distribute and combine like terms in the numerator. This would give us 2x squared plus 4x minus x squared plus 1 if we distribute the 2x to the first term and distribute the negative through over here. Again, all over x plus 2 squared. So now we can combine our like terms. Sorry, there should be a negative sign out here too. We can get negative 2x squared minus x squared will give us x squared plus 4x plus 1 all over x plus 2 squared. So this quadratic right here, x squared plus 4x plus 1, that's not factorable into whole numbers, so we'll leave that like it is. And this term here will be our derivative for the top part. Derivative for the bottom part is much simpler because our bottom function is just x plus 2, and the derivative of that is just 1. So we can write our k prime function now as another piecewise function, where the derivative of the top piece is right here, so we'll write that. So the derivative is negative x squared plus 4x plus 1 all over x plus 2 squared. That's if x is greater than -1. And our derivative is just 1 if x is less than or equal to -1. So if you have a piecewise function to start out, your derivative of that is simply going to be a piecewise function where the derivative of each piece corresponds to the piecewise function of the derivative.
The Teaching Center, UF's Learning Resource Center.